So we're going to start here with the material from the textbook on 7.1 with array processing. This is all the way back here at page 89 again. And just to reiterate, it is worth noting that there are some default standard operations that we are going to look at for leveraging the power of arrays. Here in 7.1, we are going to look at what we can do to get initial values into our elements of an array. We can also process those, so we can do math, we can do sorting, we can do things of that nature. We are going to spend special attention with what are known as the linear and the binary search of an array. This is this particular portion, the searching of an array, is going to be the breakout for the second week we spend in looking at data operations and array operations and searching and sorting operations. And the most basic but the most paid portion of this is going to be writing the contents to an array. Now remember, here it says as a report. That's not necessarily the only value in having data in an array. We can actually take an array's worth of data and do some manipulation on it. Find accounts with balances over $10,000. So we sort that down to a smaller array. Now we can say find accounts with balances of greater than $1 million. We can sort that down to an even smaller array. Now we can say, okay, let's take this smaller array and start doing some further processing with that. So we don't necessarily need to have a single use of an array. We can keep using that array to get more and more and more specific data as we go along. So the next portion here we're going to take a look at, this is on page 90. We'll just take a couple of really quick kind of updated looks at what we might do with data as an array as opposed to as several smaller individual variables. So here, example 7.1, something we've done numerous times is find the sum of the elements of an array. What we have done previously is we have taken, variable 1 plus variable 2. We have taken variable 1 plus equals variable 2 when we wanted to, develop a loop wherein we can go through and get, data from a user, or data from a file. So really the only new wrinkle we have here is that we are using elements instead. Now, something that's worth pointing out is a couple of things. Here we are using, you'll notice, the do loop as opposed to a do while or a repeat until. And remember, in a do loop, we know a couple of things that we don't always get the guarantee of knowing in the real world. In a do loop, we know how many times our loop is going to be executed. Here, that is represented by number of elements. So this suggests to us that we know this going in, which is how many elements there are going to be in our array. That's not always the case, and we'll look at an example here shortly of that, what other kinds of looping structures can we have. So this is, the crazy, fantastic power of an array as a data structure. This line is all we need in order to be able to get the sum of elements in an array. So if I have a classroom full of students and I'm looking at getting test scores so that I can create an average, I need the sum first. These three lines are all I need to do that. And that is a tremendous reduction from what it would have cost us in the way of, data entry or lines of code that we would have had with individual variables here. So those three lines, do index equals 1 to number of elements. Now, something I should note here is the text does not consistently, but for the most part, use 1 as the first index number in an array. Now remember, most shops are going to start at 0 rather than 1. So that's something to keep in mind. We would really rather have the 0 there as opposed to 1. But for the sake of consistency, again, you can continue on in this way. And that's all we need in order to sum elements using a do loop, which is really pretty great. Example 7.2, all we're doing is we're taking that and we're doing a little bit of math at the end. So in the example I verbalized here with 7.1 was we wanted to find an average. Here's the payout, 7.2. The looping structure is exactly the same. So that again suggests here that we know the maximum amount of the count rather of the elements in our array. And that's not always guaranteed to happen. But here, as in the example from the text, or from not from the text, but from the previous screencasts, would be if I know I have a hard cap of 30 students, I can say the max number of elements is 30. Here's a question. Do I want to keep adding null values here if I don't have student data read into there? That's one of the examples we're going to have to work through with the supplement here for the text, is what happens when I have an array with a max number of elements of 30, but I only have 12, say, or 20, say, elements read into there. I am going to have to do some logic there to test for, is there more data? And then at the very end, because I want to find the average here for my number of elements, sum divided by number of elements, and boom, we get good math. Here, example 7.3, and this is the last one we're really going to go through for this, is we are looking to find the largest element in an array. So there's a couple of things we have to do. First, we have to kind of call back and remember to previous chapters when we were looking for the largest of two variables. Really what we have to do is single comparisons, right? So if I have 30 and I have 35, which of the two of these is the largest? It's 35, right? We know that because I can, mentally compare 30 to 35. But in pseudocode and in logic and in algorithmic design, what we have to do is see which of the two of these is larger. If we were to, continue on with this, we would have, an array which would give us many more elements, right? So we'd have 30, 35, 37. So now I have 3 elements in my array and I'm looking for the largest of them. What this algorithm seeks to do is to find that. So we set the largest element in the array to 1. So to start off with, we're supposing that 30 at element 0, or here at element array 1, because again the text prefers 1, is our largest element. So what we're going to do is we are going to loop through starting at index 2, this is 2, and we're going to evaluate, is the next index in our array, is it bigger than or less than the previous one? So we do our compare. If array at index is larger than largest, so is 35 larger than 30? That would go this way. Yes, that is true. So then this value becomes largest. And then we would go to continue to traverse through our array. So the next time through, now we are evaluating this. We're at array index number 3, and we evaluate again. Is array at index 3 larger than the value from array at index 2? Yes, it is. So now we can go through and we've got the largest element from, or the value rather of the largest element in our array is 37. So this is a way, if we were looking for who has the highest score in a classroom, we could go through and find that. If we are looking for who has the greatest, bank account value. We could go through and sort for that. So sorting, this is essentially what that is, right? Or searching. We are looking for a value that is the largest value. And then when we are all said and done, we can print whatever the largest element was. So array operations really make this easy because look at how condensed this block of code here is. That is much simpler. It is much fewer lines of code. It is conceptually much better for us as both developers and the next developer in the chain because it's really quick for us to be able to determine, okay, yeah, this little block of code is referring to an array. An array has homogenized data. Homogenized data means we are taking a set of data and they all relate to the same thing. And we can crunch through this in really short order as opposed to relying on a stack of individual variables. So arrays are great.